All right, talking about oxyhemoglobin. All right, we talked about how oxygen is more in the lungs, so therefore, what it will do is it will combine with the hemoglobin to form oxyhemoglobin, and this is then transported in the blood. All right, hemoglobin is a blood protein, so it's a transporter of oxygen. It transports it to the cells where the oxygen concentration is low, and so oxygen will diffuse from the blood into the tissues by the breakdown of oxyhemoglobin. So the reverse reaction will occur when it gets to the tissues. All right, oxyhemoglobin starts breaking down because oxygen is low, all right, in the cells. So therefore, the reverse reaction will dominate, all right. In the lungs through the blood, this reaction will dominate. So if you write the equilibrium expression for this particular reaction, HbO2 concentration divided by Hb times O2, all right, okay. So if the O2 level is low, all right, then HbO2 is high, right? Okay. And so therefore, HbO2 needs to break down to equalize this level of, or kind of um, bring this to equilibrium, to bring the oxygen level to equilibrium and maintain the Kc value. Now, this affects us when we are at higher altitudes, all right? So, climbers, as they are going higher up at altitudes, there is a drastic decrease in atmospheric pressure, and therefore there's less oxygen in the air, all right, which means that the amount of oxygen in the lungs will also decrease, all right, because of less oxygen when being in the air that the climbers are breathing in, all right. So if there's less oxygen in the lungs, then the tendency is that the HbO2 of the blood will start breaking down to provide more oxygen into the alveoli in order to maintain the equilibrium, all right, which means that the hemoglobin that is carrying oxygen to the cells um, is now less, all right. The HbO2 concentration is much less, all right. So when the HbO2 concentration is much less, then there's less oxygen available to be given to the cells, all right. So this condition is called as hypoxia, okay. So this happens in the higher altitudes or in conditions where the person is unable to has a condition where it's has been unable to breathe properly and would need a breathing tube, etc., in order to increase the oxygen being supplied to the cells. All right. So this a decrease in oxygen would mean that the reverse reaction would occur. All right. That means there'd be less oxygen. If more of the HbO2 breaks down, there's less HbO2 available to take oxygen to the cells, and that causes that dizziness and all the symptoms associated with hypoxia. All right. You kind of lose your bearings, you become dizzy, and then, of course, you could, in extreme cases of hypoxia, it could lead to death unless you're given some oxygen through via some oxygen tanks and breathing equipment, etc. All right, temperature. So if you have a reaction which is endothermic, all right, which is heat dependent, that means you can imagine heat to be one of the reactants, all right? So nitrogen and oxygen require a lot of heat to become nitric oxide, okay? Now, if you decrease the temperature, that means you're removing this heat, you're removing one of the reactant, it'll go in the reverse direction. Excuse me, it'll form more reactants. If you increase the heat, provide more heat, then it'll go forward, right? So endothermic are heat loving So increasing temperature will make it go forward. Decreasing temperature will make it go in the reverse direction. So increasing temperature would, and this is incorrect, this should be nitrogen and oxygen, all right, not hydrogen. Increasing temperature will make it go forward for endothermic reaction. If you have exothermic reaction, on the other hand, heat is like a product. It comes out, it's being given out, all right, like the sulfur trioxide example. So here, if you remove the heat, if you decrease the heat, then it's going to make it go forward. If you increase the heat, it's like adding a product, so it'll make it go forward. Okay. So increasing temperature would make it go in the reverse direction towards the reactants. Decreasing temperature would make it go forward in the product direction. So to summarize, table 10.5 summarizes all the conditional effects that have a bearing on equilibrium, all right? So concentration, adding reactants, going forward towards product, removing, reverse. Adding a product is going towards reverse, removing a product is going forward. Because these are all gas molecular reactions, decreasing volume means increasing pressure. So that will go towards less moles, all right? Increasing pressure, you want to diffuse it, less moles. Increasing volume, you are decreasing pressure, so it goes towards more moles. Endothermic loves heat, so increase the temperature to get more products. If you don't want to get more products, then decrease the temperature. Exothermic doesn't love heat, so remove the heat, decrease the temperature to get more products. If you increase the temperature, it goes in the reverse direction, all right? Catalyst has no effect on rate. Okay. So indicate the shift in equilibrium of each change. So this is endothermic. So, and it forms nitric oxide and oxygen, nitrogen dioxide breaking up to form nitric oxide and oxygen. Adding more product. So that is going to go towards reactants 2. Decreasing the temperature. So removing heat, all right? So that's going to make it go towards the reactants. Removing some of the oxygen, removing a product, all right, make it go forward, okay, towards product. Increasing the volume, so it goes in the direction of increased moles, so 2 plus 1, it goes towards the direction of products. Removing some of the NO, removing product would make it go forward towards the product. If the reaction, okay, let's stop here because this is another section and we're talking about reaction quotient here, all right? Okay, so let's stop here and I will talk about the reaction quotient in the next video.